All right, lastly, now we've done some story problems where we didn't really know our logs, where we, had to kind of guess and check with our exponents. But now, since we know our logarithms, we can apply them to actually solve almost exactly rather than trying to guess. So we'll do our Half-Life, our double, triple problems, investing, and more, just like we always have been, but now we can solve them a little bit better. So, for example, the half-life, that's important, remember that, half-life of carbon-14 is 5,600 years. A piece of wood was found to have 78% of its carbon-14 remaining. Could it possibly be a piece of the manger in which Christ was born? Ooh, so this is a little archaeologist kind of stuff. So, remember, with decay, so we got some wood that's decaying. Remember, decay is exponential, so we'd say y equals initial times our common ratio to the x power. And what do we know? It's half-life. So what does that mean, half-life? Well, whatever my initial is, my new value would be half of that. So it doesn't matter what you'd put in. Like if I put in 100, this would be 50. So when I divide over the 100, what do I get on this left side? I get 0.5, right? So really it's just 0.5 equals b to the x power. And we've talked about that before. And then where would this 5,600 years go? Yeah, that would go down in for the x. That's our exponent there. So I'm going to write that over here. So I got 0.5 equals b to the 5,600 power. Okay. And how do I solve for b here? Well, remember, the b is not in the exponent, so I don't take any logs. But how do I get the b by itself? Well, how do I get rid of this exponent and get it to like b to the first power? Well, I take it to the what? Reciprocal power. So 1 over 5,600. So I'm going to take 0.5 to the 1 over 5,600. And what do I get? Well, let's take our calculator out and check it out. So 0.5 to the 1 over 5,600. Whammy. There we go. 0.999876. I'll round right away, but we're not going to round for our answer here. So 0.999876. All right, so here's my equation. Y equals A times our B, so 0.99876 to the x power. And now we're looking at the wood that was found had 78% left. So just think, what would its initial have started with? Well, if it hasn't lost any of its carbon-14, it's got 100% of its carbon-14, correct? And now it's at 78%, so that's it's new, right? So now in the year 2015, it's got 78% left. So I got to plug in 78 for new, 100 for A, and 0.99876, whatever that happens to be to the x. Well, I divide over that 100. It wouldn't really matter what numbers you would use as long as this number is 78% of that number. But in this case, I get 0.78 equals this guy. And now, how do we solve these guys with our logarithms? Well, to get a variable out of the exponent, we have to take the log of both sides. So I have the log of 0.78. And when I take the log of the right side, what happens? Yep, the exponent gets to come out front. So x times log of 0.99876. And to get the x by itself, we need to divide by that log of 0.99876. So really it's log 0.78 base 0.99876, however you like to type these in. And when I do it on my calculator, I'm going to use this exact number here. So what we need to do is take log of 0.78 and divide it by the log of, well, this answer. So I'm going to select my answer here. So second, and this button to get my answer, my last answer, and equals 2007. So what does x represent in this case? Years. So 2007 years ago. So that would be from the year 2015, correct? So 2007 years ago, that would be the year 8, which that's pretty close. So I would say, yes, there's a good chance. Because what? Christ was born in year 0, right? Because prior to that, it was the years BC. All right, how about mutual funds? Mutual fund is making 8.75% interest. How long will it take for the money to triple? So, for example, we use our exponential here, and instead of using b, remember we're going to use 1. Well, it's making, so it's going up, so 1 plus the rate instead of the b. So we're replacing b with, the 1 plus the rate. It would have been minus if it went down. And it's going to triple. So it doesn't matter what you use for a as long as the y is 3 times as much. And if we think about it, if I plug in a 1 and a 3 and I divide the 1 over, I get 3 right here. And then I can just plug in my 1 plus, well, this is a decimal, so 0.0875, and then to the x power. So I'd have 3 equals 1.0875 to the x. We got a variable in the exponent, so we need to take the log of both sides. And I think we can all see what's going on here. Eventually, I'm going to divide, right? So I'll have the log of 3. This x gets to come out front. So times the log of 1.0875. So I need to divide by the log of this guy over here, correct? So log of 3 divided by the log of 1.0875. So about 13.1 years. 13.1 years. So there we go. And lastly, it says in 1859, an Australian farmer homesick for England imported 24 wild English rabbits and set them free in his land. Within 6 years, there were 22 million rabbits. So he originally had 24. How many is that, 24? That would be 24. And in 6 years, there were 22 million. Holy buckets. Rabbits, huh? So what is the doubling time for rabbits? Well, before I use my nice little doubling equation that I have, right, 2 equals b to the x, what I need to do is find the common ratio first. So let's use the information that's given. Our initial was 24, so that goes in for the a, right? So I got 24 for the a. We're trying to solve for the b. And our new is the 22 million. So I got 22 million. And I need, well, what do I know the x, right? How many years was that? This looks like 6 years? 6 years. Okay, so that's right there. So we need to solve for b. So I got to take 22 million divided by 24. And I get 916,666. And what, 2/3 I think that was, equals b to the 6th. And to get rid of that 6, we have to take it to the 1/6 power. So I take this to the 1/6 power. It should be on the other side, but so let's go here. So I'm just going to take my last answer, so second answer, and take it to the 1/6 power. And this should solve for my common ratio. So 9.856. This would be a nice one to round to since this is a 0. So 9.856. So b equals 9.856. And really, I don't want to round, and we'll see what I mean by that in a second. So here's my equation. So I got 2 equals 9.856 to the x, trying to find the doubling time. So that's why I have this 2 here. And to get the variable out of the exponent, what do we have to do to both sides? Well, we got to take the log of both sides. Log of both sides, which allows me to bring the x out front. So I have the log of 2 equals x times the log of 9.856, which means then I can divide by the log of 9.856. So when I do this on my calculator, I'm going to use my exact answer. So I'm going to say the log of 2 divided by the log of, instead of 9.856, I'm going to use my last answer here. So second answer, parentheses, there it is, 0.303 about. 0.303. So what does that mean, 0.303? What does the x stand for in my equation? Well, that's years. Can I figure out how many days that is? Well, so 0.303, what would I take that times? Yeah, 365 days. Because somebody's like, yeah, how long will this take? Yeah, it's about 0.3 years. So that wouldn't really make a lot of sense. Yeah, it'd be hard to figure out. So it'd be better if I said about 110 or 111 days. That might be better. So I'd say about 111 days for the rabbits to double. There we go. All right. So just some problems dealing with our exponential form and logarithms.